Hello everyone, we're going to take a quiz over solving polynomials. Now, you're not going to need to use a quadratic formula, but you might need to find some complex zeros or some irrational zeros. You're going to see everything in the graph though, so you'll be able to know, hey, I can identify my zeros, I can do this. So first thing, if it says you're going to start with this x cubed, I want you to graph that in Desmos, and you can see I have the graph. Is that this one, x cubed minus 2x squared? So here's the graph. Now, the first thing we're looking for are where are the x-intercepts. I know the answers. They're -3, 1, and 4. Okay, I'm going to get the answers right. I just need to show my work and get to them. It does not matter which of these three zeros you pick, -3, 1, or 4. I'm going to pick -3. Doesn't really matter which one you pick. I'm going to plug in -3. So I'm going to use synthetic division, and since I know it's an x-intercept, I better get 0. Okay, it's degree 3, so there should be 4 terms, and I better get 0 because it's -3, 0. So I bring down the 1, then you multiply, then you add, then you multiply, then you add, then you multiply. Hey, I got 0. Good. If I didn't, I did it wrong. So because I had degree 3, and I just factored out this -3, 0, now I have degree 2. So these are the coefficients for a degree 2 polynomial. I'm going to write that as 1x squared minus 5x plus 4. And I think it's important you realize that if -3 is a 0, then I just factored out x plus 3. Now, we had degree 3, now we're at degree 2. We can solve any quadratic, even if I have to use the quadratic formula. Like I said, you won't on this quiz, but you will on the unit test. So first, let's factor. So find numbers that multiply to 1 times -4. What multiplies to 4 and adds to -5? It's got to be -4 and -1x. So I split the middle on this quadratic, then I factor by grouping. X minus 4. The GCF of those two is -1. Now my factors are x minus 1, x minus 4, and remember, since -3 was a 0, one of the factors must be x plus 3. So where should I see my zeros? At 1, +4, and -3. So let's draw that. 1, +4, 1, 4, and -3. And again, I can use Desmos to see the graph, -3, 1, and 4. Look, -3, 1, and 4. I just have to kind of sketch it. Looks something like this. But I can see in the graph all three of those zeros, -3, 1, and 4. It's just a matter of can you use synthetic division to help you get there and factor. You have to do both of those things to receive credit for this problem. The last thing is describe the end behavior. Remember, x goes to infinity. That means as you go to the right, and x goes to -infinity means as you go to the left. So what I'm talking about is this guy. As I go to the right, what does y do? Y goes up. So we say y goes to +infinity. That's like saying up and right. Y goes to infinity is up, and x goes to infinity is right. So it's going up and right. It's going down and left. So as it goes left, y goes to -infinity. That's saying up and right, down and left. That's the math notation for end behavior. Okay, that's the first one. They're all going to be pretty much like that. So the first thing we do is we graph it. I have it right here. And I can see intercepts at -2, +2, and +4. So I'm going to plug in -2 just because I'm working left to right, but it doesn't matter. -2, 8, 8, -32. Bring down the -2, and now you multiply, and then you add, and then you multiply, and then you add, and then you multiply, and again, you better get 0. We did. That's good. So this was degree 3. Now I have a degree 2 polynomial. I have a quadratic. -2x squared plus 12x minus 16. And since -2 is a 0, I factored out x plus 2. -2 plus 2 would give you 0, so that's the factor. Now I can solve this however I want. I'm going to factor it. I think first thing though, if you have the coefficient, I'm going to factor that out. So let's factor out the -2. And now it'll be x squared. 12 divided by -2 is -6. -16 divided by -2 is +8. And I'll just ignore this for now. It's there, but it doesn't matter. So I'm going to split the middle, find numbers that multiply to 8, and add the -6. That would be -4 and -2. And when you factor by grouping, you get x minus 4, x minus 2. I'm going to put the x plus 2 here, and I'll also, just to be really thorough, even bring down that negative 2, even though it doesn't affect the zeros. So where are my zeros? Based on my factored form, if I want to know where this equals 0, I would say, well, that's 4, 2, and negative 2. So I should see in my graph at negative 2, positive 2, and positive 4, I have x-intercepts. And if I look, I do. Negative 2, positive 2, and 4. This graph is negative in odds, so it goes the other way, but it's the same idea. Okay, 3 intercepts, so there's nothing fancy. Again, as x goes to infinity, as you go to the right, this thing goes down, so we say negative infinity. And as you go to the left, this thing goes up, so we say positive infinity. Down is negative infinity, up is positive infinity. So you can see my endpoints there. Great. Okay. Nothing too fancy. Let's try another one. Ooh, when you zoom out on this, when you see the graph, it's like, wow, there's only one intercept. So what I should expect here is I'm going to get some messiness. I'm going to plug in 1 because that's the only 0 that I see. And I have a feeling that I'm going to get complex zeros for this one. So the coefficients are 1, negative 1, 16, and negative 16. Now we do synthetic division. Negative 1 plus 1 is 0. 0 times 1 is 0. 16 plus 0 is 16. Multiply. Again, you get 0. But this one's weird. It was degree 3, so this is 1x squared plus 0x. Well, I'll just write that as x squared plus 16. And since 1 was a 0, x minus 1 is a factor. Now, you could do quadratic formula here, but since there's no b term, remember, if it's just x squared, you can just write a little equation, x squared plus 16 equals 0, and solve with square roots. So subtract 16, and when you square root, you get x equals plus or minus, don't forget, the square root of 16 is 4, and since it's negative, it's imaginary. So those are imaginary zeros. And then the third 0 is at x equals 1. So the only one that I see in the graph is 1, and we saw earlier the graph is just kind of this curve that doesn't really have a lot of detail to it, so it kind of just looks like this. Just do your best, okay? But I should see one of your intercepts is at 1, and since these are imaginary, they don't show up. So end behavior, as it goes to the right, that means to the right. As it goes to the right, this thing goes up. So this is positive infinity. And as it goes to the left, this thing goes down, so negative infinity. One more. So I've got 3 intercepts. Ooh, those are gross, though. So those are going to be irrational. I'm going to have a radical in here somewhere. But that's okay. Let's use the one that we know, negative 5. Let's plug in negative 5. 1, 5, negative 7, negative 35. Bring down the 1. Now we multiply. Add, multiply, add, positive 30. Good, I get 0. So it's kind of like the last one. It's x squared, but then it's going to be minus 7. And since negative 5 is a 0, x plus 5 is a factor. And again, you don't have a b term, so you can solve this using square roots. Just set it equal to 0. That means x squared is 7. And when you square root both sides, you get x equals plus or minus, don't forget plus or minus, radical 7. And then the third 0, since I plugged in negative 5, is at negative 5. So let's draw that. And where are those decimals? 2.6. So if you're not sure, like, did I do that right? The square root of 7 is 2.64. So you can see that's the 2.646 right there. So I'll try and draw this as best I can. Go back to the graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I know I have intercepts at negative 5 and then negative 2.6 and positive, I didn't need to go that far, positive 2.6. Okay? And it looks like this. Okay. And now, again, as you go to the right, this thing goes up, and as you go to the left, it goes down. So, you're going to need to use synthetic division, you're going to need to use Desmos, but once you get the intercepts, you should have no problem finding all of the zeros, even if they're gross, so they can be radicals, or they could even be imaginary, and that's okay. So make sure you finish the study guide, make sure you get all those delta maths done, and make sure you hit that like and subscribe.